So here we go. So just some of the big ideas, right? The big takeaways, because I want to make sure that you're really focusing your studies and making and thinking about the things that we did. So thinking about that practice assessment that we did, let's talk about some of the big things that you need to know. All right? So first of all, remember that we talked about how to find the equation of lines. And remember that it was a different process depending on the kind of line that you were looking at. So the first ones we looked at were those straight lines, the linear equations. Does anybody remember what we did in order to find the equation? There was a formula.
Look for it. Wasn't it like you look for a pattern or something?
Well, you're going to find pieces of it, but remember there was a formula for linear equations. Anybody remember what that formula was?
Y equals mx plus b.
Genius. That's it. Y equals mx plus b. Right? So in order to use it, first, find m, which is the slope, right? And if you have the graph, you can find it by counting. Just count from one point to another. Remember, it's rise over run. And remember, slope can be negative or positive depending on if the line is going up or down, right? If the line is going down, it's what sign? Negative, good. If it's going up, then that means it's positive. Good deal. So just find any 2 points on the graph and count from one point to the other, right? But remember, it has to be one of those integral points, those points that you can easily measure between the, because you can't really count from a fraction, right? So make sure it's a point you can easily count from. Excellent. Oh, I'm sorry. Y'all use y equals mx plus c, which it makes more sense anyway, because c is the letter that stands for constant, some number. Okay? All right. Then, right, so we have your slope. Next, choose any point on the line. And we like to use the y-intercept if we can, because it makes x equals 0. It just makes the equation easier to solve. But it doesn't have to be the y-intercept. It can be any point on the line. Okay? Then substitute x and y from the point and solve to get c. Okay? Obviously, you would have already put in the m in there as well. Okay? So you put your x value there, your y value there, and solve it to find out what c is. Yeah? Remember that? Okay. Now, we also talked about transformations. Remember, if you shift it to the right or left, then that means you're either adding or subtracting to the x value. Yeah, remember that? And you've got to change the sign, because remember, you're plugging it in with the x. If you move it up or down, which thing is that effect in my formula?
The c.
The c. So you can either up or down, and that you just use whatever sign you have. Okay? Now, if you add to the x, remember, add just to the x. The x value itself. Okay. Now, let's talk about the second one. When we had those quadratics. And remember the graph, the quadratic, that was that parabola shape, the U shape, up or down. Now to find the equation for a quadratic, did we have a formula for it, really? Not really, not like y equals mx plus b, but we had two forms. Remember that? You better, because you're gonna have to know both of them for the test, because you don't know which one you're gonna have to use. And if you'll remember back on that other test, we had to find the equations of parabolas, right? The quadratics. Remember you had that one where it was y equals x plus or minus b plus or minus c. Oops, I'm sorry. And that thing was squared. Remember that?
Was there an A in that one before the brackets?
Ah, yes. There can be an A. There can be a multiplier. Thank you. I'm sorry. Okay. And this one is used when you know the vertex, but not the x-intercepts. So you usually know the vertex and the y-intercept. Remember, they were pretty nice to you. You knew the vertex and the y-intercept, so you could plug it into this formula. Remember that the plus or minus b was how far it had been shifted either right or left. And the plus or minus c is how far the vertex had been shifted up or down. Remember that? Then you plug all that stuff in along with an x value and a y value to find your a, just like you had to find the c before. But your b and your c you can read straight from the graph. And the reason we liked to use the y-intercept again was because it turns that x into a 0, so it makes our a very easy to solve. So you plug in some point to find a. All right. Now again, I'm not doing examples of these because we're not focusing really on the math here. I want you to focus on the knowledge. And then you can go back to your homework and find examples of these. But these are things that are the big takeaways from the class. May be on the test, may not be on the test. Okay? Remember the other form was y equals x plus or minus a times x plus or minus b plus c. Oops, and there's an a there too, isn't there? Okay? And you remember when you use this one? When you know the x-intercepts. Remember that? You just plugged them right into the a and the b part. Those are your y-intercepts. Okay. And then again, you can find out, because you couldn't read the vertex part of it, right? Okay. So it just depends on what information you know. If you know the vertex, then you use the one with the squared. If you know the intercepts, then you use the one with the 2 brackets, because there are 2 intercepts, right? Depends on which thing you can read. And then you can plug in a point to work it out to find the rest of to solve the equation for the rest of them. Okay? And the third one were those exponentials. Okay? Do you remember how we found the equation of an exponential? Writing the equations for exponential graphs. Maybe, maybe not. Okay. Remember, you're still going to count from a point from the asymptote. So first, find the asymptote. That's that line that it gets closer and closer to, but it never quite gets there. Oh, I'm sorry, the formula is y equals positive p times x plus or minus b plus or minus c. And the asymptote gives you your c. Remember that? So wherever it is, if it's down 2, then your c is negative 2. If it's up 3, then your c is positive plus 3. Yeah? Then find where the graph is 1 unit below the x-axis. Oop, I can't spell axis. Find where the graph is 1 unit below the x-axis. Do you remember that? It's an easy point to find. I'm lying to you. The asymptote's what I'm trying to spell. Below or, okay, above the asymptote. Forgot which one I'm doing here. Okay, depending on which way the graph opens, if it opens up or down. So 1 unit above the asymptote, or 1 unit below it's 1 unit above. I think most of all of these that we did opened upward, went up like that. Okay, then count from not the intercept, but the point 0, 1. So remember the basic parent graph of those all went through 0, 1. Count from 0, 1 to that point. Okay. And the left or right number is your B. Remember that C and B are always, B is always right or left, C is always up or down, right? And the asymptote is always up and down, but the B that you get for this number. Now, they were pretty nice to you. What did they always use? What did they usually make P?
2.
Yeah. But it could be 3, but usually it's 2. And I don't think they'll stray very far from that. Okay? All right. Those are huge pieces, takeaways, and they also include a lot of the stuff that we did. Okay? Let me just look at the index and see what else I see that I think will be critical ideas for you. Okay? So definitely x-intercept, what's that? Where it crosses the what?
X-axis.
X-axis, yeah. And remember, parabolas can have 2. Linear will only have 1. Exponential will only have 1. If it crosses the x-axis at all, that doesn't have to happen. Y-intercept is where it crosses the y. The slope, we only measured slope for the linear ones. And then you can just get that from counting if you have the line. Okay. Parabolas, remember moving that vertex vertically or horizontally. Vertical is always the C, up or down, and you just use the sign you have. Horizontal is the B, and remember you're going to put that with an X, which is going to change its sign. So if you went right 5, you're going to use negative 5, even though it went to the right. Okay. The vertex or the turning point, being able to find those values. Okay, and being able to find the equations of exponentials. Now remember them with piecewise, we couldn't find the values for them, but you might as well put those on there. So for piecewise, what's important to remember is that if it's flat, that's a constant, right? So you get y equals some number, whatever number you were at, up or down, and it's c, so up or down, right? Okay. What if it's doing this? What does that look like? It's a linear going down, so you can find a linear. What if it was doing this? Linear going up. And remember, those piecewise functions were combinations of those. And be careful, if you have an open circle, that means it does not include that point. If it's a closed circle, that means it does, if it's a dot. Okay? So things to keep in mind. I think that if you know all of those, obviously you still need to be able to do them in the applications. But if you know those ideas, then you're in pretty good shape for the test. All right, those are the memorization parts. Okay, I misspelled piece, didn't I? You guys have to help me out there sometimes. All right.
Mr. Sell,
Yes.
I just had a quick question.
Of course, that's what this is for. What's up?
Is this like an end of the topic test to see where we are, or does it actually count for credits?
This is the one that it's not a practice to see where you are, even though you'll do the external. Remember, this is the one that you would use to do a derived grade. So this is a grade for QMC. Now you'll still do the external function, the external test at the end of the term. But if you're not able to take it, this is the grade you'll have to use, right?
I see.
So
we won't get credits, or we will?
I don't know. How does that work on externals?
I don't think we do. If this is a derived grade,
Yeah,
I think
it's a
credits
derived
come from the external. This is just like it's like a serious practice test.
Yeah, this grade does count. Let me just kill the recording here.